This is a tutorial on how to use chi-square test in Excel. The chi-square test is a non-parametric statistical test used to examine whether there is a significant association between categorical variables. It does not assume a normal distribution, making it useful when dealing with frequency data or counts. The most common is the chi-square test of independence. This is used when you have two categorical variables and want to see if they are related or associated with each other. So this problem is an example of the chi-square test of independence. Here is the problem. A civil engineer is studying whether the type of foundation, spread footing, pile foundation, or mat foundation is associated with building performance after an earthquake. No damage, minor damage, or major damage. A survey of 90 buildings after a recent earthquake provides the following observed data. So here is the observed data of the 90 buildings after a recent earthquake. So for the buildings that use spread footing, 12 has no damage, 8 has minor damage, 10 has major damage. A total of 30 buildings who use the spread footing. For the pile foundation, we have 18 buildings that have no damage, then 6 for minor damage, and another 6 for major damage, and a total of 30 buildings who use the pile foundation. And for the last type of foundation, the mat foundation, we have 24 buildings who have no damage, 3 buildings who have minor damage, and another 3 buildings for a major damage, with a total of 30 buildings who uses the mat foundation. So we have an overall total of 90 buildings. So we want to test at the 0.05 significance level whether foundation type and building performance are independent. Based from the problem, we have two categorical variables, the type of foundation and the building performance after an earthquake. And each combination has the frequency or the count in terms of the number of buildings. So, given those factors, we can use the chi-square test of independence. And we also want to test if there is a association or relation between the foundation type and the building performance. So let's write first the hypothesis. So we have the null HO and the alternative H1. For the null hypothesis, so there is no association, so no difference or no effect or no relationship. So there is no association between the foundation type and building performance. Or the two variables are independent with each other, meaning they have no association with each other. For the alternative, so we will negate the null, so there is an association between the foundation type and the building performance. Or the two variables are dependent with each other, meaning there is a relationship between the two variables. First step in performing the chi-square test, we need to write the observed data or the observed frequency. So I will just copy this one, not including the row total and column total. So this is our observed frequency based on the survey of 90 buildings after a recent earthquake. Also, we need the expected frequency. So those are the variables that we need to compute for the test statistics. So we have the observed frequency based on the survey, and for the expected frequency, we need to compute that. For the formula of expected frequency, we will use this one. So the expected frequency or the expected value is equal to the row total times column total over the overall total. So we need to get first the row total and the column total, and also for the overall total on the observed frequency. So actually that was computed here based on the problem. But if that is not given, we can also compute for that here in Excel. So row total and column total. So for the row total, we just need to get the sum or the total of this row. So for the spread footing, so we will highlight on these three data, then enter. Then do the same for the next two rows for the pile foundation and the mat foundation. So we can just copy the formula by dragging this down. Then we need to get the column total. So we need to get the sum of this column for the no damage. So we will just highlight on this data. Then we need to do the same for the minor damage and major damage. Or we can just drag this to the right. And for the overall total, so we need to get the overall of the row total or the column total. So you can do either because you will be getting the same total. So I will get the total of the row. So that is 90. So let's compute for the expected frequency. So for the spread footing under no damage, let's click on equal. So the row total for the spread footing, that is this one, 30. Then we need to multiply by the column total. So same column for the no damage, so that is 54. Then let's close that. Then divide by the overall total. So the overall total is 90. Then enter. So let's do the same for all these cells. So for the minor damage, the row total again. So we are still here in the spread footing, so we will use the first row, that is 30. Then multiplied by the column total. So we are here in the column minor damage, so we will click on the minor damage total. Then divide by the overall, which is 90. So let's do the same for all the cells. So here is the computed for the expected frequency using the formula. So after that, we can now compute for the test statistics using the formula of the chi-square test. So the formula of the chi-square test is, so this one, we have x squared, which is the chi-square value or the statistics, is equal to observed value minus expected value raised to 2 over expected value. The observed value is O minus the expected value raised to 2 divided by the expected value. So I will just copy on this table. Then clear the contents. So we do the formula. So we get the observed value for the spread footing no damage. So this is 12. close that in the parentheses. Then subtract the expected frequency. So same combination, spread footing and no damage. So that is 18. Then we need to square that, or raise to 2 divided by expected frequency again. So that is the answer, which is 2. So we do the same for all the cells or the different combinations, or we can just drag this down to copy for the formula, then drag this to the right. So that will be our chi-square for each combination. So to get the chi-square statistics, that is the x raised to 2, we need to get the summation of all this. So we can type on sum, then we highlight these all cells, then enter. So that is the chi-square test. Then we need to solve for the DF, or the degrees of freedom. So the degrees of freedom for the chi-square test, so here is the formula. That is the number of rows minus 1 times the number of columns. So the number of rows is the type of foundation. We have 3 types, so that is 3 minus 1. Then we need to multiply that by the number of columns minus 1. So for the number of columns, that is the building performance. So we have 3 minus 1. So our degrees of freedom is 4. Then we need to solve for the p-value, or the probability value of this test. So in order to do that, let's type on equal, then chi-square this dot RP. So choose on that. Then we need to highlight on the x value, or the chi-square value. Then for the degrees of freedom, then let's close that. So our p-value is 0.038293375. So for our decision, because we have the p-value, we can compare this with the alpha. So our alpha is test at the 0.05 significance level. So our alpha is 0.05. So our p-value now, which is 0.038, which is approximately 0.04, that is less than the alpha 0.05. So our decision will be reject the null hypothesis. So for our conclusion, because we have rejected the HO, that is in favor of the alternative hypothesis. So meaning, there is an association between the foundation type and building performance. Meaning, there is a relationship between the foundation type and building performance. Also, we can use another formula here in Excel to get the p-value for a chi-square test. So we can use the formula chi-square test. So click on that. So we need to highlight the actual range. So that is the observed frequency. So we just need to highlight the data, not included the labels. Then we need to highlight on the expected range. So that is the expected frequency. So highlight on this one. Then let's close the formula. And we will be getting the same p-value, which is 0.03829. And using that, we can compare it with the p-value again to decide whether to reject or do not reject the null hypothesis. So that is how we perform chi-square test using Excel.